Welcome! Today, we're going to become climate detectives. We'll explore all the clues scientists use to understand our changing planet, and we're going to break it all down so it's super simple and clear for everyone.
So, here's our game plan for today. First, we'll look at what's happening right now. Then we're going to take a journey back in time to find some clues hidden in nature. And finally, we'll piece everything together to solve the puzzle of our planet's climate story.
Every good investigation starts with a question, right? So what exactly are we trying to figure out?
You know, we hear about climate change all the time, but what's the actual proof? How can scientists be so sure? That's exactly what we're going to dig into piece by piece.
This right here is the heart of our investigation. The two key words to focus on are rapid and last 100 years. Think of it like this. The Earth's climate usually changes at a kind of slow, walking pace. What we're seeing now is more like a full-on sprint, and it's that speed that we're trying to understand.
So, where do we find our first clues? Well, let's start with the evidence that we can actually measure right now using tools that you're probably pretty familiar with.
Okay, this is our first and most direct clue. I want you to picture thousands of thermometers scattered all across the land and sea, all taking the Earth's temperature. Together, they give us this really precise, real-time health check of our planet.
And here's what they found. 1 degree Celsius. Now, that might not sound like a lot, right? I mean, for a single day's weather, who cares? But think of it as the entire planet running a fever. That 1 degree represents a massive amount of trapped heat, and that has consequences.
And one of the biggest consequences of all that extra heat is found in our oceans.
Now, what's really fascinating about this slide is where this extra water is coming from. Yes, some of it is from melting ice, for sure, but it's also because as water gets warmer, it actually expands. It takes up more space. So this is kind of like two clues in one.
So you see, it's not just one clue we're looking at. It's a whole pattern. The oceans are warmer, glaciers are melting, and sea levels are rising. All these clues are pointing in the exact same direction. Our world is warming up.
Modern records are really clear, but they only go back about 150 years. So how on earth do we know what the climate was like thousands or even millions of years ago? Well, let's look at the clues hidden in nature. This is where it gets really cool.
To look way back in time, scientists basically become detectives, and one of their best tools is this, the ice core. I want you to imagine a history book where every single year gets its own page made entirely of ice. It's just an incredible process. By drilling deep into places like Antarctica, scientists can pull up ice that formed 400,000 years ago. And get this, tiny air bubbles trapped inside are like little time capsules, telling us exactly what the air and even the temperature was like way back then.
And to go even further back in our climate history book, we have to look at the ocean floor. Over millions of years, layers of mud and sediment build up, and they trap tiny fossils. These fossils tell us whether the ancient oceans were warm or cold, giving us a story that goes back millions of years. It's wild.
Here's another amazing natural record, and this is one you might have actually seen for yourself on a tree stump. Every single year, a tree adds a new ring. It's like a new chapter in its life story.
And that story tells us about the climate. When the weather's warm and wet, the tree has a great year and grows a lot, leaving a nice thick ring. But in a cold, dry year, it struggles, and the ring is really thin. So by reading these patterns, we can map out climate conditions for hundreds of years. Our final clue is surprisingly small. Ancient pollen. It's so tough, it can survive for thousands of years buried in mud. And by identifying the pollen, we know what plants were growing. That tells us what the climate was like because, well, different plants prefer different temperatures. Okay, wow. We've looked at a lot of different clues, from our modern thermometers all the way to ancient pollen trapped in mud. Now, let's step back and see what story all these different pieces of the puzzle tell us when we put them all together. This is really where all our detective work pays off. Just take a look at this table. We've got thermometers giving us a snapshot of the last 150 years. We've got tree rings telling a story over hundreds of years. Ice cores take us back thousands of years, and sediment cores go back millions. The amazing thing is, they are all telling the same story. Each one is like an independent witness, and they all agree. So, what's the final verdict from all our evidence? Well, it's not just one clue pointing to a warming world. It's the thermometers, the rising seas, the melting ice, the tree rings, and the ancient pollen all telling the exact same consistent story. The Earth is warming, and it's happening pretty quickly. So,
our investigation is complete. We followed the clues our planet has left for us from today all the way back to the distant past, and the story they tell is really clear. So that leaves us with one final, important question. Now that we've read our planet's story, what are we going to do in the next chapter? Thanks so much for joining me on this investigation.